Okay, hi there and welcome to my presentation on fatigue and recovery 2.3. So the causes of fatigue. Fatigue is the decline in muscle ability to create force. There are three muscle fiber types. They all fatigue at different speeds. As the contraction speed and strengths are different in a sporting activity such as marathon running, the fibers used are going to be slow oxidative, as they provide the body with constant but weaker strength contractions the whole time. The slow oxidative fibers fatigue by lack of carbohydrates and fatty acids. Once this happens, the term hitting the wall takes place. The fatigue depends on the event taking place. For example, if you are running a marathon and have a good, efficient aerobic system, the resistance to fatigue will be very high if you are staying at a steady state. But if you have a low resistance to fatigue, this means that even though you are not running anywhere near a full sprint, you would still experience fatigue because there are not as many slow oxidative fibers in the leg muscles as a professional marathon runner will have. This is the same goes for sprinting, in that a professional sprinter will have lots of fast glycolytic fibers, so they're able to push themselves through the whole race anaerobically. But for an average person who is not a professional, they will not have as many of these fibers. They will fatigue quicker because they don't have as many fast twitch fibers to use. So the depletion of energy sources, we've got creatine phosphate and muscle and liver glycogen that deplete. Creatine is what is responsible for replenishing ATP in the ATP-PC system. With the help of the enzyme creatine kinase, it is found in the liver, kidneys, and the pancreas. ATP is the main source of energy in the muscles, but it only lasts for 5 to 8 seconds, so it needs to be resynthesized. This is where creatine comes in. Creatine kinase mixes with ADP and out. Sorry. Creatine kinase mixes with ADP, and out of this reaction we get creatine and ATP. However, we can also run out of creatine during anaerobic exercise such as weightlifting or a 100-meter sprint. This is where creatine supplementation, as you can see in this picture here, comes into play. Creatine monohydrate basically gives the body more creatine than it would originally have. This means that more ATP can be resupplied as a result of this, and it means we can keep working for longer and harder. This is why people use it in the gym, because you can get heavier sets and more reps out of each set too, because it allows you to have more powerful contractions. As far as supplies of creatine go, it depends on how much of an athlete you are. So if you're an Olympic standard sprinter, you would have a high creatine stores from training so hard, and therefore this would mean you have a good sufficient amount of creatine during a race. Someone who is not a professional sprinter will not have as big creatine stores as the professional, because their body is not used to the daily aerobic exercise, which means their body would not be trained itself to produce more creatine. The creatine is also found in the muscles. So the depletion of glucose and glycogen. Glucose is used in the muscles as this is where it is taken from. It works with sugar, and if there is not enough sugar, something called hypoglycemia can occur, and as a result of this, there is not as much blood glucose. In extreme cases of lack of glucose and glycogen, this can result in something called bonking. This is where the body is completely rid of glucose and glycogen, and mostly occurs in something such as a marathon, and is what people experience when hitting the wall. These fuels would be used in a sport such as marathon running. It is made by a process called glyconeogenesis. This process is good in that the result of it is glucose, which the body can use as fuel. However, it is a slow process and is not easily accessible to the muscles. Glycogen decreases, but only if we are doing anaerobic exercise. If we were doing, for example, aerobic exercise in a marathon, you're always topping yourself up with water and maybe even some glycogen gels, which keep you topped up. And as it lasts for quite a while during steady state exercise, these gels are perfect during something such as a marathon. So moving on to waste products during fatigue. Carbon dioxide, blood lactate accumulation and the acidity, and also heat. So carbon dioxide or CO2 is produced in the muscles as a byproduct from the muscles contracting. When this is being produced, receptors called chemoreceptors pick up how much there is and will send impulses to the brain, where the brain will then react and get breathing rate to increase in order to expel more CO2 at a faster rate. Also in this process, doing this, more oxygen is also being brought into the alveoli. The CO2 is extracted during expiration by diffusion from the bloodstream into the alveoli as there is a low partial pressure of CO2 there in the bloodstream. Once it is in the alveoli, it comes out of the lungs when expiration takes place. A CO2 buildup normally happens in exercise such as long distance running when the CO2 is not being expelled at the same rate which is getting produced if we are perhaps going faster than our normal steady state rate, because the CO2 is being produced quicker than it is being taken away from the body, than it's being exhaled during expiration. The lactic acid, the LA system stands for lactic acid. This is a harmful byproduct being produced during anaerobic exercise, and it comes from pyruvate, which occurs during anaerobic glycolysis. The reason it is harmful is because it causes a burning sensation in the muscles that it is acting upon. This would occur in exercise such as high repetition weightlifting, because your muscles run out of oxygen, so therefore they have to use lactate, which can be converted into energy. However, the muscles cannot use the lactate at the same rate it is being produced, so therefore the lactic acid builds up in the blood and causes us the pain. A data example to show how lactic acid increases with speed is when Jacob Green was doing the lactate threshold test. His starting lactate was 1.07 millimoles, and it was taken every 3 minutes for about 12 phases. And on the final phase, his ending lactate was 4.11, so it's gone up 3 and a bit %, which is quite a significant amount. So this is definitely showing how when you exercise like Jacob was, he was running that the blood acidity is always going up when exercising. So moving on to heat. Heat is also a byproduct of different types of exercise, aerobic and anaerobic. The reason this happens is because when the muscles contract, they produce heat because of the chemical reactions that cause the muscle fibers to contract. When our muscles heat up, our body has to find ways to cool us back down to normal body temperature. Otherwise, it becomes extremely dangerous, even if our body temperature goes up to even 4 degrees above normal temperature. The receptors that detect heat change in the body are thermoreceptors. When they pick up that the muscle temperature has gone up, they send an impulse to the brain, where the brain triggers physiological changes to cool us down, such as sweating, and also making the hairs on our arms and legs go flat so they're not trapping any air as the air goes past them. This is actually not a very efficient way of cooling us down, because when we sweat we lose a lot of salt, which means our body gets dehydrated quickly. So now moving on to neuromuscular fatigue. In this section is the depletion of acetylcholine, reduced calcium ion release, and also nerve impulse transmission, the changes that happen there. So the depletion of acetylcholine. Acetylcholine is a neurotransmitter and is found in the vesicles. As you can see in this photo, these circles are the vesicles, and those dots within them are the actual acetylcholine. At the neuromuscular junction, there are vesicles, and within these vesicles is the acetylcholine. When the muscle contracts, the acetylcholine are released at the end of the motor unit, and depending on if enough of these acetylcholine are released will determine if the muscle is able to contract or not. If enough of them are not released, then the enzyme called acetylcholinesterase, which when there was not enough acetylcholine, these are in charge of picking them back up and taking them back to the vesicles in order to have enough for the next contraction. The acetylcholine works according to the all or nothing law. This means that unless there is enough acetylcholine for the muscle to contract, the contraction will be unable to take place, and if there is not enough, the muscle will begin to fatigue as a result of this. So the reduced calcium ion release. The calcium ions play a key part in the muscle contraction, as they are crucial during the slide and filament theory. Their job during this process is to bind to something called troponin, and when this happens, the sites on the actin are exposed. The myosin can then attach, and then the power stroke can take place. The calcium works efficiently as long as it is being produced at a rate where the power strokes can continuously take place. So the calcium is always needed for muscle contractions. However, when the calcium is pumped into the sarcoplasmic reticulum, some calcium can leak and can be lost, which as a result is a decrease in the levels of calcium. When this decrease occurs, this means that the actin cannot properly join onto the binding site, and so therefore, as a result of this failure, the muscle contractions begin to become weaker, and that is thus fatiguing. The nerve impulse transmission rate. When we are exercising, the nerve impulse transmission begins to speed up, as the central nervous system is in need of more information because the muscles are contracting more, so it needs to know whether we are getting fatigue or if we need more oxygen, etc. As we know, when we are exercising using the aerobic system, lactic acid can be produced, and inside this lactic acid are hydrogen molecules. When these hydrogen molecules go into the bloodstream, it lowers the pH volume in the blood, and this means that there is an increase in acidity. When this happens, the conduction rate of the muscle fibers decreases, which means that the impulses are stopping being sent out as fast. This means that we have a lower decrease in peak twitch. Also, the result of all this is that there is a decrease in force of the contraction. Okay, so now moving on to recovery, I'm going to do that in a separate video.